So now that we've gone over solving systems of equations with the augmented matrix, um, we can apply this concept to now equations with three or more variables. So here, let me get rid of this first. Let's say we have the three equations, 3x minus 2y plus 5z equals negative 17. I'm going to call this equation 1. And then we have 2x plus 4y minus 3z equals 29. And that's going to be equation 2. And then we got 5x minus 6y minus 7z equals 7. And that's going to be equation 3. So when we set up the matrix, we're going to set it up like this. So it's going to be exactly how we did the matrix with two variable equations. We're going to have all the variables on one side and the constants on another side. So we're going to set this up as just exactly as they appear. All the x's in this row, whoops, that's too big. So we're going to have 3, 2, then 5, negative 2, 4, negative 6, 5, negative 3, negative 7, and then we'll show the constants as with the separated by this vertical line, negative 17, 29, 7. So if we're eliminating a variable by linearly combining it, what we're really doing is we're trying to add two of the equations together to get their coefficients equal to 0. So if we're going to eliminate, like, let's say x with using equations 1 and 2, for equation 1, we're going to multiply it by 2, and for equation 2, we're going to multiply it by negative 3, because that's going to, when they're added together at that point, it's going to equal 0. So this is going to get us 6x minus 4y plus 10z equals negative 34. And this is going to get us negative 6x minus 12y plus 9z equals negative 87. Then adding these together, we're going to get 0x minus 16y plus 19z equals negative 121. So now that we have eliminated x, we can rewrite this matrix now as it's going to be 3, because the top equation is going to stay the same, and then 0, because we're taking this equation now and replacing it with 2, and 5. And then we'll have negative 2, which are staying the same, then negative 16. Then negative 6, then 5, 19, positive, and negative 7. And then we're going to show the coefficients again right here. So that will be negative 17, negative 121, and positive 7. So, basically eliminating a variable by linear combination corresponds to placing a 0 in the appropriate place in the matrix. So the operations we're going to do on this matrix are going to be the same, but our goal is to get it basically as ones and zeros. So you want a 1 where you're solving for the variable you want, and then zeros for the other variables, and then just a constant on the other side. So I'll go through a whole example problem in the next slide, but an example of how this would look would be as 1, 0, 0, then 0, 1, 0, and 0, 0, 1. And then solving for coefficients on the right side. So we'll have 2, 4, -3. So how this equation would be read is 1x plus 0y plus 0z equals 2. So really all this is saying is x equals 2, y equals 4, and z equals -3. So here we have the augmented matrix, right? And we're going to want to diagonalize or basically get it into the form that's solving for each variable. So we're going to write our steps like in the notation we've been using before. So the first thing that we're going to want to do is we're going to want to multiply the second row by -3. So I'm going to write that as just, I'm going to indicate the row number with a circle. So row 2 multiplied by -3. And we're going to add then, we're going to then add row 1 multiplied by +2 because that is going to eliminate this variable. So I'm going to write plus row 1 multiplied by 2. At the same time, we can actually also eliminate a variable, a second variable with 2 other rows, and we're going to do that by multiplying row 3 by -3, and then adding row 1 multiplied by 5. So that is going to allow us to eliminate another variable. So when we perform those operations, we're going to end up with the matrix 3, 0, 0, -2, -16, +8, 5, 19, 46, then -17, -121, and -106. And then here are the coefficients. They're separated by this vertical bar. At this point, we can eliminate one of the y variables by multiplying the third row by 2, and then adding the second row to it, just adding the second row multiplied by 1, because that will allow the -16 and the 8 to be eliminated. So on this third row, we're going to multiply 3 by 2, and then adding just the second row. And so that is going to yield the augmented matrix 3, 0, 0, then -2, -16, and now this 8 has been eliminated because we've added, we've basically added -8 to it. And so 5, 19, 111, that's just through the addition, and then -17, -121, -333. So now what we have here in this third equation is 0x plus 0y plus 111z equals -333. So now we can solve for z by just dividing row 3. We're going to take row 3 and divide it by 111. And that is going to yield the matrix 3, 0, 0, -2, -16, 0, 5, 19, and then now we have 1, and then -17, -121, -3. So now what we've done here is we've solved for z, and we know that 0x plus 0y plus 1z equals -3, or is just z equals -3. So now we're going to need to eliminate a couple other variables. So what we're going to first do now is take row 1 and, whoops. And we're going to multiply it we're gonna take row 1 and then we're gonna add row 3 multiplied by a -5 to it. And what that is going to allow us to do is eliminate another variable. At the same time, we're gonna take row 2 and leave it the same, and then add row 3 multiplied by -19. Basically, what that is going to allow us to do is eliminate the 5 and the 19 here because we're making 0. So what that is going to get us is the 3 and then the 0, 0 are going to stay the same. Then we're going to have -2, -16, then another 0. And now the 5 and the 19 have been eliminated, so we're going to have 0 and 0. And we've already solved for z, so there's a 1 here. And then this is going to be -2, -64, and -3. So now we can solve for the y because we have the -16y equals -64. So we can just take row 2 and divide it by -16, and we'll be solving for y. So then that is going to yield the following. We're going to have 3, 0, 0. The -2 is going to stay there, and then this is going to become 1 because we've divided by -16, then 0, and then 0, 0, 1, and then the constants. So we'll have -2, and then this will become +4, and then this is going to stay as -3. So now we've solved for both z and y, because we have 1y equals 4, so y equals 4, and z equals -3. So now we're left with just the 3x minus 2y equals -2. That's the only, x is the only variable that hasn't been solved for. So we can take that row and we can basically take row 1 and multiply it by itself. We're just going to leave it as it is, multiply it by 1, and then add row 2 multiplied by 2. And so that is going to get us the following matrix. 3 and then 0, these are going to stay the same. Then 0, because we've now eliminated the -2. So now 0, 1, 0, then 0, 0, 1, and then the constants, which now are 6, 4, -3. So now just on the top row, all we need to do is divide by 3 on both sides, and we'll be solving for x. So that will get us 1, 0, 0, 0, 1, 0, 0, 0, 1, and then 6 divided by 3 would get us 2, and then 4, -3. So now we have successfully diagonalized the matrix, and the solution to this is going to be the following ordered triple. We're going to have x is going to equal 2, y is going to equal 4, and z is going to equal -3.